and we'll pick up where we left off with antipsychotics. All right, so pop quiz. Does anyone have any concepts of what antipsychotics might treat specifically and what they might do? Any ideas here, just based on the word antipsychotic?
Sometimes they can induce sedation.
Okay, sometimes can induce sedation. So antipsychotics are primarily used to treat schizophrenia and similar disorders, like similar psychotic disorders or mood disorders like bipolar disorder, which sometimes can have psychotic elements, but that's not like a guaranteed part of it. So this is prescribed kind of on an as-needed individual basis, and they predominantly act on dopamine. And this is important to remember, right? Because we've talked in the past about schizophrenia is thought to be a disorder predicated upon the dopamine system not functioning properly. And this can cause behaviors that are not congruent with reality, or they can cause breaks from reality. Now, does anyone remember what the opposite of that is? If you have too much dopamine activity, it may lead to psychotic symptoms, but if you don't have enough dopamine activity, what might it lead to? We've talked about this in the past related to stimulants. Thoughts on this? Too much dopamine activity can lead to psychotic disorders and psychotic experiences. Too little dopamine activity can lead to what? Think stimulants. Depression. Well, if you don't have a very active dopaminergic system, then yeah, you're going to be less motivated to do things. But I'm thinking of a specific disorder that can arise from not having enough dopamine activity or efficiency, etc. One that can arise from stimulant use or excessive stimulant use. Does anyone know?
Parkinson-like symptoms?
Yes, exactly. Major high five for that one. Parkinson's-like symptoms. I know that I've said this a couple times, so it might sound like a trick question when I bring it up, but I mean it every time, that people that are chronic, heavy, high-dose stimulant users can sometimes experience loss of motor control, which is a symptom in Parkinson's as well. So this is something that we can kind of, actually, I'll come back to that in a second. So some potential side effects of antipsychotics might be shakiness and stiffness, might be involuntary muscle movements, might be weight gain, as well as sleepiness and sexual dysfunction and lowered seizure threshold. Now, we were just talking about Parkinson's, right? So what do you think antipsychotics do? If one of the side effects is shakiness and stiffness, how does this all work together? Come on, this is not that big of a logical leap. Take a leap of faith or we'll be stuck here for hours. Suppresses dopamine, exactly, suppresses dopamine. So if you have a disorder that causes excess dopamine activity in the brain, it might lead to psychotic symptoms. The goal then would be to suppress that dopamine activity. So one of the consequences would be loss of motor control or other Parkinsonian symptoms. Now, there are some ways that we've tried to combat that, which we'll come back to in a couple slides. But I also want to point out this major thing right here, which is lowered seizure threshold. Now, for those of you that don't give a shit about medications and are only here to talk about controlled substances, which I get, honestly, that's my area of expertise. That's what I like to babble about for hours. I understand that. But this is a really important thing to take note of, especially for those of you in ground control, paying attention to how medication interactions can not play nice with illicit or recreational substances, and also how they might mimic the effects of some recreational substances. So we talked about how you might experience Parkinsonian symptoms from antipsychotics because of the suppression of dopamine activity. And so researchers looked at that and they were like, that's bad. That's probably not something that we want, and people don't really enjoy feeling this way and feeling so sedated like this. So let's try something different. And they decided to split this group into two pieces. So you have typical antipsychotics, which are dopamine antagonists. They decrease the effects of dopamine, right? So they decrease the likelihood of psychotic episodes by decreasing dopamine activity that might be too high. And then you have atypical antipsychotics, which suppress both serotonin and dopamine. Now, this was done in an effort to kind of reduce the strain on suppressing dopamine to reduce the likelihood of side effects. And this, again, is a tailored medication experience. So typical antipsychotics will have increased neuromuscular side effects, so motor control side effects, and increased loss of sexual function, but you're not going to gain as much weight as you would on an atypical antipsychotic. Yes, that's right. Whereas atypical antipsychotics, you'll gain more weight, but you're not going to have as many neuromuscular side effects or libido loss. And this is a simplified version of it, but it's a cool thing to note, right? That we're seeing that serotonin influences weight gain, because we've seen this, and sexual function, we've seen this in SSRIs previously, right? That some medications make you gain weight, and oftentimes they're serotonergic, they act on serotonin. Now, this is the part that if you're really into controlled substances is most relevant to you here. So pay attention for 30 seconds, then go back to playing like that one penguin game on Flash Player. So antipsychotics lower the seizure threshold. And this phrase seizure threshold, I think we've mentioned in the past, but just to reiterate what it is, it's basically the level of brain activity required until it's too much and you have a seizure. Because seizure is an excess of brain activity happening, right? So that's part of the reason that if someone is epileptic, they need a medication that's going to reduce convulsion likelihood. It's going to reduce electrical signaling in the brain. So can anyone think of a different category of drugs that might be used to treat seizures if we're reducing electrical activity in the brain? Don't think too hard about this one.
Benzos?
Exactly, benzos, which fall under the depressant category. Right, another virtual high five, which is not as satisfying as a real one, but we can't touch each other. So a typical dopamine antagonist, a typical antipsychotic is going to have an interaction with MDMA and psychedelics and alcohol and grapefruit. Atypical antipsychotics have a major interaction with psychedelics. And the reason for this is that both dopamine and serotonin will influence your seizure threshold, right? But particularly serotonin. So when you add this into the mix, the risk just like goes up pretty drastically in some cases. Additionally, mixing antipsychotics with SSRIs is a really bad idea. So a lot of the time, you might look at a certain drug and be like, okay, I need to check the interaction for this. And you might look at its chemical mechanism, and there isn't anything super obvious that would make it a dangerous interaction with a controlled substance. But if you dig a little deeper, oftentimes, if it's something that acts on dopamine or serotonin, the risk is from seizures, of lowered seizure threshold, and things compounding that lowering of the seizure threshold. So that's important to note. And I get asked all the time, can I combine an antipsychotic with a psychedelic, etc.? And you have to do more digging. You have to ask, is it a typical antipsychotic or an atypical one? And also, you need to be aware of the increased risk of seizures. So it's a different animal than trying to mix with SSRIs, which will often dull the effects of various substances kind of unpredictably. So speaking of which, let's go right into benzos. So a benzo is an anticonvulsant, right? It reduces electrical signaling in the brain, which means that it's a sedating substance. And antipsychotics are also sedating in their own right, but benzos are a sedating substance. Now, typically benzos are prescribed for panic disorder, but this is a really controversial category of drugs for a lot of reasons, and I have a lot of feelings on it, so I'm not going to say too much right now. Generally speaking, they're prescribed for anxiety, right? But they're also used for insomnia because they knock you out, as well as seizures. But the main thing that they will induce on kind of a prescription level is sleepiness and sedation, which makes sense. They're depressants, right? Like they reduce brain activity. It does make sense. But then there's also this dependence that can form. And benzos are extraordinarily tricky in this regard, because they are massive, massive respiratory depressants. And oftentimes they lead to blackouts. I'm sure many of you are familiar with this concept that you can be barred out, and from Xanax in particular, that's definitely the best known benzo. And being barred out means that you effectively black out in a lot of cases. You just like dip for a while. So a benzo is a GABA agonist, right? It increases the effectiveness of the neurotransmitter GABA, and GABA is responsible for slowing your system down. Just as all depressants do, increases GABA, slows your system down. Now, here's the problem. A lot of the time, benzos are prescribed as a sleeping aid, but benzos are not FDA approved as a sleep aid. After 3 to 14 days, benzos are no longer actually sleep promoting in a way that is not just disrupting REM cycles, according to major studies that have been released on this. So when doctors prescribe benzos for sleep purposes, it effectively, the prescription effectively loses its effectiveness after only a couple of days or weeks if you're lucky. After 4 months or so of continuous use, there is no evidence of continued anxiolytic effects, of continued anti-anxiety effects from benzos. I'll TLDR this. Benzos are not meant to be taken for more than 2 weeks, approximately. They're not. And there's a huge body of evidence behind this right now. And obviously there's, always more stuff coming out, but we're seeing a real problem, which is that benzos are underestimated, overprescribed, and also are frequent contributors to overdose fatalities. Frequent contributors, maybe to a degree that people aren't aware of. In fact, benzos were, I think, rivals to opioids in 2017 in terms of overdose visitations to the ER. Benzos are like up there with them. So if we're looking at the relative harm scale, they fall somewhere in the middle. And a big brick of what causes this potential issue, as compared to a lot of other substances here, is dependence. This blue bit is dependence. And this is a really underestimated part of benzodiazepines, is they are extraordinarily dependence-forming substances. In fact, some of the only other drugs that rival this quantity of dependence as measured in relation to other drugs are tobacco, nicotine, right? Meth, crack, heroin. They have comparable dependence ratios. And obviously this isn't like honed into a point. There's only so much we can do with this kind of quantitative data, but it's super important to keep this in mind. Now, over time, chronic excessive use of benzos can lead to heart problems and weight loss and blood vessel damage and muscle twitching. And this muscle twitching is an interesting one to think about, right? Like we do see this kind of rebound effect, and I'll come back to what the rebound effect is in a little bit, but it's important to think about depressant-like drugs in this way. When you're reducing your system's activity, you can think of it like a really powerful spring that is being pushed down on, right? When you release the pressure, especially without like slowly releasing it, it just flings upwards again. The spring will like go up and bounce and return to its normal state. This happens with depressants, and it is the reason that they're so damn dangerous to withdraw from. That is the thing, and we'll look at that in more detail in a second. So some of the major benzos are Xanax, right? And the generic name is alprazolam. Then there's Klonopin, which is clonazepam, Valium, which is diazepam. It's hard to remember which of these generic names belongs to the brand name, but these are the major ones. And I'm sure that many of you are at least partially familiar with these. But definitely Xanax is the #1 in pop culture right now. And benzos are actually, I got the numbers wrong. According to this, benzos are actually more commonly involved in ER visits than opioids as of a couple of years ago. Like, that's a lot. That is a huge number of ER visits. I don't think Ambien is a benzo. Is Ambien a benzo? No. I have to look into that. I will have to look into that. The rest of this is accurate, though. Benzodiazepines are involved in a lot of deaths, truthfully. And complication deaths are a really major part of this because benzos that are taken in recreational contexts are usually combined with other things, mainly alcohol, in a lot of cases opioids. They're complementary highs, they compound each other exponentially. Now, can anyone tell me what the #1 biggest danger of this would be, of mixing something like Xanax with alcohol? Biggest danger. You're muted.
Me?
Yeah.
Oh, I actually just wanted to give more time for anyone else. I don't want to talk all the time. Okay, respiratory depression.
Exactly. Respiratory depression. Nice. So respiratory depression is caused by things that reduce the system's overall activity, mainly the respiratory system, right? And respiratory depression leads to what? Death. Okay, it can, but what's an intermediate step there? You're not breathing as much, therefore, lack of oxygen to the brain. Lack of oxygen to the brain, and what else? This is a dead giveaway. Okay, I meant the heart. But yes, also the lungs. There is no oxygen in the lungs if you're not breathing. But like if you're not getting enough blood flow, that just really got me. Thought it was a trick question. Oh, that makes sense. So if you're not getting enough blood flow to the heart, then this can cause cardiac arrest, right? If your heart stops, or if you're not getting enough oxygen, you can go into cardiac arrest. It's this whole mess. And cardiac arrest can happen either before or after your heart stops, but wait, no, what? I don't know what I'm talking about. Just pretend I didn't say that. But anyway, the point is respiratory depression is a major issue here. But there's also this risk of psychological dependence. And this is a concept that we haven't really fully dove into yet. So I'll give a little teaser on this right now, which is that there's a difference between addiction, physiological dependence or physical dependence, and psychological dependence. Addiction is it's complicated. It's not just a disease of reward pathways, but it can be boiled down to and ultimately results in neurological changes that make your brain hypersensitive to the rewards of something specific. So you don't feel rewarded by other things as much as you do one specific thing. That's addiction. That's when there's craving, there's reinforcement, there's mental preoccupation with the thing. Then there's physical dependence, which is when your body doesn't function properly without this substance present. You go through withdrawals, you build a tolerance, etc. Those things can happen separately from each other. There can be one and not the other. And then there's psychological dependence. And this one's a little bit harder to fully define, but the gist of it is that psychological dependence occurs when you are alleviating a psychological problem with a drug, and then you remove the drug, and the psychological problem is worsened. So this is different than craving the drug. This would be a situation more like you have anxiety. You start taking benzos for anxiety regularly, then you stop taking benzos and your anxiety is worse. Even if you're not craving benzos that much, your anxiety is worse. And sometimes you might recognize, oh, this is because I'm not taking benzos, so you want to continue taking them, but you're not craving them, you just want your symptoms to go away. So that's the major difference between psychological dependence and addiction, is that psychological dependence is the re-emerging of psychological symptoms outside of the presence of a drug, whereas addiction is craving that substance, regardless of its health impacts. Does that make sense? Does anyone have questions on that? Wait, does that mean you can't technically develop a psychological dependence if you don't have a psychological problem? That doesn't seem right. No, it's not necessarily. Oh, it's a hard one to like put hard definitions on. It's kind of a nebulous thing to explain in words. But effectively, addiction involves specific craving and seeking of a substance, right? Or not necessarily even a substance. It just is obsessively craving and seeking something because your brain has been tuned to be sensitive to it. Psychological dependence is wanting your psychological state to feel differently and having there be an external factor that's responsible for it. So you're not going out of, it's not like you are just craving and craving this thing. It's that that thing happens to be important for your mental health. Does that make sense? I'm going to, yeah, I think so. Okay. If we have more clarifying questions, feel free to ask and I can go back to it. Even when you are taking benzos as prescribed by a physician, benzos can be dependence forming at around 3 weeks. 3 weeks. That is not a long time. This is the major issue that we're having with prescriptions of benzos, is that they fall into the category of drugs that are not being prescribed with informed consent. So we've seen this with opioids too, right? People will take them as prescribed by a physician and still experience physical dependence and potentially also addiction and potentially, and potentially psychological consequences as well. So this spring thing that I mentioned, right? You can think of depressants like benzos and alcohols as pushing down on the excitatory activity in your brain, the activity in your brain that's like, let's get connected, let's talk to each other, let's do the thing. You're pushing it down. If you release that spring without tapering, without doing anything about it, then it's going to rebound like crazy, and you're going to have potentially very serious effects, excitatory effects that can lead to what's called excitotoxicity. Now, this basically means that your brain goes from being really chill to really fucking not chill really fast. And in that process, you're at high risk of what? What do you think might be the major risk of withdrawing steeply from these depressants? Knowing what we know about the spring being released, what is the big risk here? Just spitball. Okay.
Relapse?
Okay, relapse, it could be. It depends on the situation though. Not everyone is experiencing a relapse if it's like not everyone's experiencing an addiction-oriented thing. But yes, seizures, that's right, seizures. Now, that's because you're pushing down all this electrical activity in your brain for a while, and then you release the spring and the electricity just goes and goes because it's compensating. As you're adding this depressant effect to your system's kind of fighting back. It's like, well, wait a second, we're below baseline right now. Like, we need to be going back to where we were. So it is kind of on its own time increasing the activity of this system to compensate. Your body's always trying to reach homeostasis, right? That's the goal. So that's why this is so dangerous. And excitotoxicity, when your neurons are acting too frequently, too quickly, et cetera, can actually cause a phenomenon where your neurons die or are damaged, which is excitotoxicity, right? Like, it is brain damage effectively. And this is really dependent on how severe the withdrawals are, right? And how long you've been taking the substance and the dosage of it. But this is why if you're going to try and cut off drinking or benzos, it must be under supervision, and it should be directed by a physician. This is extremely dangerous to do on your own, extremely dangerous. The withdrawals from benzos are extremely notorious as well. They are widely regarded as being more difficult to withdraw from than opioids. And part of the reason for this is something called protracted withdrawal syndrome, which a lot of prescribers actually don't know about and will actively say that's not a thing when it is a well-documented thing. And protracted withdrawal syndrome is where over the course of like a year or more, a person can continuously be withdrawing because it's just this weird kind of like intermittent recovery system. And what makes benzo withdrawal so hard is that one day might be fine and the next day might be unbearable, and it's completely random for a lot of people. Now, this isn't a homogenous experience. A lot of people don't experience that kind of like off and on, but for the people that do, it's extremely debilitating. So if you know someone that's withdrawing from benzos or encounter someone who is, have empathy, because that withdrawal experience can really, really take a toll on a person's body. All right. I'm actually not going to show this. And the amazing thing is, with such a long acute phase, many detox inpatient programs are only 3 to 5 days long. Yep. Now, part of the major reason that many substance use disorders are so difficult to recover from is because substance recovery programs are incredibly expensive. They're often booked, and they also are just not usually long enough. And the ones that are long enough are just like completely inaccessibly expensive. They're so much money, so much money. So Something that's important to note here as well is this concept of a cross tolerance, where if you take one substance, it increases your tolerance to another substance. Benzos and opioids and other depressants share a cross tolerance. So particularly benzos and alcohol. If you are drinking and also doing benzos, then your tolerance to both will go up. And this can be a pretty easy way to build a tolerance very fast if you're mixing these two things, and also keeping in mind that mixing any of those things is going to reduce your overall central nervous system activity, right? This is the major risk here, is lack of oxygen. You are not breathing enough, you're not getting enough oxygen to your cells, your heart stops, and if you're not breathing for 4 minutes or more, then you are at risk of brain damage. Always do CPR, call 911. If you don't know CPR already, it's a really important thing to know, actually, for everyone, I think. Most of the people that we see in emergency room visits are actually older groups for benzos as opposed to for opioids. And this is kind of interesting, right? Because benzos, I think, are a category of drug that are often prescribed to older groups like Gen X, for the purpose of treating anxiety disorder and insomnia. But we do see a lot of really serious adverse incidents within these groups. And it's also an important thing to note that we see an increase in the deaths related to these things as the age groups go up. Granted, this is an older chart right now, so the numbers are probably different this year than it was from, I think this was 2017 or 2016 again. And again, there's this issue of benzos being a massive statement in pop culture right now. Like, look at this. Like, there are jerseys for Xanax, Adderall, and Vicodin. And a portion of the proceeds from the sales of this collection will be donated to the Medicine Abuse Project. Like, I'm sorry, what? Whose idea was that? Like, whoa, that is not going to achieve the goal that you pretend to be wanting to achieve. And then there's also, like, even Lil Xan and Xanarchy, and, like, and Lil Peep, like, there's so much pop culture around Xanax in particular, and very little understanding of the fact that, similarly to cocaine, it's not like doing Xanax once is going to kill you. You know, that's not what we teach here, and that's not the truth of it, unless, of course, you take, like, a massive quantity and overdose and then stop breathing and die. Like, yes, that can happen. But people still just don't have any access to truthful resources about what benzos are and how they work, and the fact that doing them recreationally is potentially going to lead you down a road where you become physically dependent or develop an addiction pathway through a variety of sources, totally by accident sometimes. And this is all because of lack of resources and popularization in media without having any kind of, like, response of being able to seek education on the subject. So now it's time, finally, to get to a little bit of the science behind addiction. And I wish that I'd had time to put more information in here about the psychosocial elements of addiction, because that is a major part of this that I didn't put enough about in here when I made this course, and I need to go back and do that. But for now, we'll just talk about the brain part, like how addiction actually happens. So addiction, again, remember, ultimately manifests itself in the form of a disorder of your reward pathways in your brain. So remember, which neurotransmitter is involved in reward again? Reward neurotransmitter.
Dopamine.
Dopamine, thank you. The reward neurotransmitter is dopamine, right? So we can immediately kind of pick up on the fact that this is going to be a disorder of your dopamine system, where your dopamine system basically starts recognizing things too strongly as opposed to other things as being valuable inherently. And the two qualities of addiction that manifest themselves are that a thing is, or two things that make a particular stimulus potentially addictive, is that it's rewarding. So you feel good about doing it, and when you're doing it, it's motivating, you feel accomplishment, and it's reinforcing. So you want to do it in the future. There's something about it that makes you want to do it again. It feels good, you want to repeat it. Feels good, want to repeat it. So let's look a little bit at the science behind this.
Dopamine's
Now, I want to point out that this video has some super problematic depictions of this, and I've been meaning to replace it, but I didn't. So we'll actually maybe use this as an opportunity to have a discussion about what's problematic about this, which is a pop quiz.
purpose is for survival, so craving can be good. The problem happens when our wires get crossed and our maladaptive brains get confused on what to crave. Here is a good example. Take Mr. Blue and Mr. Red. Red has a relatively normal brain terrain with the right levels of serotonin and dopamine. Blue, on the other hand, is an addict. He has a nucleus.
Okay, what are some immediate problems here?
You're calling the person an
Addict,
addict.
normal.
Mm-hmm. Exactly. Okay, so we see a normal brain terrain. Bitch, we don't have a map of what is considered to be a normal brain terrain. So how would we be able to compare this from baseline? And then we have the word addict. What would be a better way of phrasing this if someone has developed an addiction to a particular stimulus or substance? How would we say it?
A person with an addiction to substance X.
Yeah, that's person-centric language. That's great. That's how we would say something like that.
Incumbents hypersensitive to dopamine and low baseline serotonin levels.
This is so bad.
The two crave an ice-cold beer after work. At this point, both are craving in exactly the same way. The difference we see is after each gets what they want. Blue, low serotonin, never feels satiated.
What's another problem with this? What did we just say about addiction?
Well, so I guess maybe it's not that you don't feel satiated, it's that you do it repeatedly.
Well, one might lead to the other in some cases. And this is a very individualized thing. There are some people where they have a more difficult experience with feeling satiated from a stimulus to begin with, and that causes the repetitive seeking. There are other people where through time and through exposure, the repetitive seeking builds up because that feeling of not being satiated increases the more exposure they have to it.
So even when he has beer after beer, there is not enough serotonin to tell him he has had enough. On the other hand, Red wanted one beer and one beer was enough. He had enough serotonin to make him feel satiated.
Also, I'd like to point out that serotonin is probably not the chemical that's going to be primarily involved in this. Yeah, I know.
The conclusion here, based on neurological and
This is the worst part. You ready?
clinical research, is that a brain with a nucleus accumbens hypersensitive to dopamine
Oh, not this, maybe.
plus low baseline serotonin levels equals addiction.
That's the worst part right there. So there's a lot to unpack in this video, but a really major part of it is the fact that this is titled The Pathology of Addiction, which sounds very reputable and contains this incredibly stigmatizing language and faulty science to begin with. And this is what people have access to, right? Like, this is what drives this notion that you are an addict that has an addiction who is just never satisfied, and that's that. From a scientific perspective, there's a little tiny bit of truth there, which is that our current understanding of, also I hate how it's just talking about neurotransmitters as though that's the only thing that goes into addiction. Exactly. So there are two major things with neurotransmitters that are a part of addiction from our current understanding, from my current understanding. The first is the dopaminergic system. So a dopaminergic system that is less sensitive to reward overall, and this can happen through genetic factors, it can happen through socialization factors, it can happen through all kinds of factors that makes a person's brain less sensitive to other sources of dopamine, other sources of reward. Sometimes that's the case. Other times, a person's brain becomes sensitized to a specific thing and less sensitized in other areas because of the introduction of that specific thing. So it really does depend. And the bit about having low baseline serotonin, I'm actually not positive on our current scientific standing on that, but there might be some grains of truth to that as well that are more related to kind of the psychosocial element of this. And the psychosocial element of addiction is arguably the most important, okay? And something that a lot of people don't give enough weight to. And this gets complicated, right? Because when we're talking about someone that's really struggling with a substance, we want to validate the fact that your brain chemistry does indeed change to make it really fucking hard to give up or cut down on your use of a particular thing or your engagement in a particular activity when your brain is super sensitized to it. And we need to have empathy for that. And we need to incorporate an understanding of the fact that if someone's in it or if someone's predisposed to it, it's neurological, at least to a degree. We have to remember that, because otherwise it becomes an issue of telling people, basically, you're not strong enough. This is a moral failing. You just need to change your mindset. And it takes away from the very scientific part of this. That's one part of it. Then there's the other part of it, though, which is that sometimes that mentality can lead people to feel like they are helpless, like they can't control this thing, that your brain is just this way. And it really takes away the hope from people that are struggling with this kind of a situation. So it's a very delicate balance here. And the psychosocial element of this is that everything that happens in your life and before your life leads up to a kind of a general risk level of experiencing something like this. And this should also not be discredited. This is also vastly important in this realm. So for instance, someone who is genetically predisposed to mental illness, someone who grows up in marginalized demographics or in poverty, which, there's a crossover, obviously, might be more at risk of having this experience in the first place. And then these two things work together. So you really need to look at the entire case history of a person, and you need to consider the fact that even before they were born, there may be factors that contributed to this. Extraordinary stress in someone that's having a kid prior to that child being born can cause genetic changes. Like, this is the reason for generational trauma in some part, because people's DNA is literally decided by the level of stress and pain and agony that their parents go through. Like, this is a real thing. So it's just so important to look at this as a whole picture. Some things within a person's control, many things not within a person's control, and many things environmentally decided. So when we look at someone that has a substance use disorder, when we look at someone that is struggling with, for instance, addiction, we need to see the entire person. And this is part of why so many of our treatment programs don't work and aren't targeted towards the people that they're supposedly helping, because they don't take into consideration the whole history, and it becomes an issue of, you fucked up. This is your fault. This is your failing. Sometimes there is some of that, like, we can't say that it's completely black and white, but anyway, that's my spiel on that. Now, going back to the neurological part of this, there's a protein called delta phos B that your brain produces. And this protein basically is responsible for dictating what your dopamine neurons respond to. This is a simplified version, right, as usual. But this protein will be like, okay, we're going to make some new dopamine neurons and they're going to be sensitive to this thing. Now, when you have what's called delta phos B overexpression, you have too much of this protein doing its thing, it causes changes in the reward pathways because this protein is being overexpressed for a certain stimulus. So before, you had more of a kind of broad development of which dopamine neurons would be sensitized to what, but when this protein gets overexpressed through time, it can sensitize the brain to specific stimuli. So this means that you're basically redirecting resources. You're redirecting mental energy. You're redirecting neurological power towards a specific stimulus, which again could be so many different things, like sex and gambling, various substances, like all kinds of stuff. And this causes the kind of, not all of, but definitely at least a large part of the neurological basis of addiction, is that certain substances cause delta phos B expression more than others. So this is an interesting thing to look at when you're looking into the pharmacology of a drug, is to look at delta phos B expression. This is just one piece of it. This is not anywhere near the entire picture of what causes what's the word I'm looking for? Predisposition, predilection, whatever, to the development of addiction. But it's an interesting thing to look at when we're considering the profile of a drug. So let's get it firsthand.
Try and think about not eating. Your brain's trained in the knowledge that it needs fuel to keep your body alive. And also you're in the routine of eating at certain times in the day. If you were to think about not eating, you know, you're really trying to break a cycle of habit and dependency, which is like trying to not use drugs. And the more you think about not eating, the more your brain will want to eat. The more you think about, I can't eat, the hungrier you get, and you think further that I just really want to eat. And the more it gets on the brain, you know, that you would not eating feel tired and weak, and you'll be thinking, if I just went down the shop and got some food, if I just went to the kitchen cupboards and got some food, I wouldn't feel like this way anymore. That's what addiction feels like.
Empathy, cornerstone of this course. Hope you take that away. So when we're looking at this genetic predisposition, approximately, and this might be outdated data, I need to look back into this, but approximately 40 to 60% of your vulnerability to addiction is thought to be genetic, and approximately 40 to 60% environmental. Now this is huge. Okay, this is a really major thing to consider here. One person might have a completely different experience with a stimulus than another person if they were raised in very similar environments. And that's important to keep in mind, right? Like, I'm sure that we've all known people that have had very different experiences with one substance than another person has, and that may be partly genetic, or it may be partly environmental. So some of these genetic vulnerabilities may include a lower dopamine sensitivity. Now, we've said this earlier, but drug dependence is when your body doesn't function as it is supposed to in the absence of this drug, right? Now, this can lead to withdrawal, which is when you go through unpleasant symptoms when you don't have the drug in the system, or tolerance, which is when you need more of it, right? Basically, your body has adapted. It's always trying to reach homeostasis. That's what we've taken away from this, right? So just to reiterate the difference between these two things, dependence is when your body has adapted to a substance and will not function normally without it, basically. Addiction is changes in reward pathways and compulsive seeking, like you are fixated on it. You want this thing, even if logically you understand the consequences of this thing. You can conceptualize it like breaking up in a toxic relationship or losing a loved one. Like, it is really difficult. It is extremely difficult to break with this kind of a pattern. Okay. So we can start, well, I haven't even prepped these because I didn't think we would get here today. What do you guys think? Do you think we should start with psychedelic culture today or wait until next time and end a little bit early? Thoughts, prayers, feelings? Down to start? Okay. Let's do it. So, psychedelic culture spotlight, apparently, which is happening on October 30th. Not correct. So let's do a quick recap of October 28th, 2019. What are some potential reasons why SSRIs might be delayed in their action? Does anyone remember this? Wild guesses. Why might it take several weeks for SSRIs to start working? I'm going to wait. I have all the time in the world. It's quarantine. I could pick up crocheting, cross-stitching. The receptors are being blocked. Okay. You're in the definite right territory here. So one of the ideas is that potentially over time, because that's how SSRIs work, right? Like, you're totally right. That's how they work. They jam themselves in the transporters so that the serotonin accumulates and binds more repeatedly, more bang for your buck. But one of the reasons that they're thought to take a while to work is that over time, fewer transporters are made naturally in the brain, which means that your brain kind of builds up its own SSRI-like activity. That's one thought. What's another one? Think about some other substances that are thought to induce antidepressant effects and why and what they do. Give you a hint. It has to do with growth.
I want to say that enough serotonin needs to build up between the terminals, but I don't fully believe myself.
Well, that is kind of an acute effect of SSRIs, is that you have more serotonin building up. But what I'm looking for here is we have fewer reuptake transporters through time, that's right. But then there's neuronal growth, neurogenesis. This is the other piece that might come into play here. And this is something we've seen with other drugs, right? Like, which other drugs can you guys think of that are thought to have a neurogenesis component, where over time they inspire your brain to create new neurons or create new connections? What other drugs?
K.
Ketamine.
I hear psychedelics and ketamine. And yeah, okay, I'll take those as categories, right? So acid, psychedelics, ketamine, whatever you want to call them. Absolutely. Like particularly LSD and psilocybin and ketamine have been shown through neuroimaging to create new neurons over time. And this makes us more robust problem solvers. It makes us more capable of handling conflict and problems and emotions because we have more neurons to do it with, right? Like when you're a kid, a buttload of your neurons die within a couple of years of you being alive. And that's called synaptic pruning. It's basically you're born with way too much going on in your brain and you're kind of snipping out the unnecessary stuff and forming something in the meantime, which is kind of cool. If you haven't already conceptualized your own beautiful brain as being basically a block of clay that someone chipped away at and chiseled a melon out of, then now I hope that that's how you envision it for the rest of your life. And then the last thing is inflammation reduction. And inflammation, as I've mentioned in prior lectures about cannabinoids, is thought to actually be a potential serious player in depressive symptoms. And inflammation is implicated in all kinds of things, even like depression and cancer treatments. And a lot of anti-inflammatory treatments reduce depression. What are three major categories of psychotropic medications? And you don't have to get them exactly right. So if you want to just say categories about medications, go for it. Think about what they do. What medications are prescribed for?
Stimulants.
Okay. What else? Think about surgery and mental health. What are two major things that would be prescribed for surgeries or mental health? Okay, anesthesia, anesthetics, that's right. So things that are like sedating. What else might we need in surgeries? We knock you out and we do what else? Otherwise, it would probably not be very comfortable.
Are you talking morphine? Like opioids?
You're on the right track. I'm looking for analgesics. So the category analgesics. And I know that these are a little bit more specific than what we've talked about in the past. So it makes sense that it'd be a little bit sticky to remember them. But yes, anesthetics, so sedatives, analgesics, which are pain relievers. And I'm also looking for mental health. And mental health can have to do with all kinds of different things. Which substance poses a very dangerous interaction with MDMA? What is the #1 biggest risk of serotonin syndrome? I don't know if anyone's ever gotten it. Everyone always forgets this. Every time I teach this class, no matter how many times I say it, people are like, I have no idea. MAOIs, yes, Jay, 10 points. Exactly. MAOIs. Why? Guesses. We always like guesses. Seize the bull by the horns, sweet DrugsCo.
I feel bad I keep talking, but there are only 11 of us.
Yeah, it
And there's
happens.
some people who never speak, so
Go for it, honestly.
my guess. What substance
MAOIs?
yeah, right. Emily, so they inhibit what is it? Opioid inhibition or something. Whatever. They can make things more potent.
Yes, you're right on the more potent. MAOIs don't do a lot of
They
opioid
lower the
stuff.
seizure threshold.
MAOIs do lower the seizure threshold. That's totally correct.
Okay, I'm done.
That's fine. Jay's also got it right in here. MAOIs kill the guys that clean up the extra neurotransmitters in your synapse, so you end up with way too much stuff in serotonin syndrome. Couldn't have said it better myself, Jay. That's exactly right. So MAOIs kill your bouncers, right? MAO, monoamine oxidase, is a chemical in your brain that acts as a bouncer. It goes around and cleans up and destroys extra neurotransmitters floating around, including serotonin. So when you inhibit that and hug it and like kill it and crush it, it's not cleaning up all the extras. So you have a lot of serotonin floating around, which can lead to serotonin syndrome. What 2 substances can cause fatal withdrawals? I want to hear a rousing chorus for this one.
Alcohol.
Okay, that's right. And what else? Diego's
Enzymes.
got it. Yeah, and benzos, exactly. Diego's got it in the chat. What substance requires the presence of an MAOI in order to work orally? You got to eat an MAOI for this one to work if you swallow it.
The plant that activate, yeah. Yeah, I'm gonna stop talking now.
Jay's got it, DMT. Right, so that's why ayahuasca is a brew that contains an MAOI like Syrian root or passion flower and DMT. You put them together and then the Syrian root prevents your bouncers from killing DMT as it goes through your stomach. And this one says God mode because no one ever remembers this, and then everyone remembers it because it says God mode. But what's the protein that we just talked about that when overexpressed can be a player in addiction?
Delta phosphate.
Exactly, delta phosphate, that's right. Glad we're getting through the recap just in time to probably do the recap next time also. This, you won't remember, that's Syrian rue, that is a naturally containing MAOI. What are these things?
You snort out of them?
Yes, you do. You snort out of them. They're called tutors. And then skin picking and itching is pruritus. And so I guess I'll just give a rundown of what we're going to be talking about in the psychedelic culture lecture next Tuesday. Hopefully we'll have class next Tuesday. We'll talk about indigenous and historical uses, the people that have been involved in the literature, which I know probably sounds really boring, but we're talking about psychedelic culture, so it's not, I promise. Cultural shifts that have happened, the music and arts associated, and cults. We'll get into a little bit of cult stuff next time. That's all for today.